ladies and gentlemen, I'm very pleased to give a talk here today as I represent a country which has a very low geothermal potential if you compare it to what I heard within the last days. So please don't expect that I can present figures with huge plants or a lot of megawatt capacity. The German market nevertheless starts to develop also for power production, which is actually pushed by a high feed-in tariff. So you get 25 cents per kilowatt hour guaranteed by the government if you produce electricity. So that's why the market started up in Germany. And I will at first show you something about my employee and then go on with some words, maybe a little bit more as planned in the beginning about the German market, because it's very different and from what I heard so far unique. And we'll then go on to the operation, environmental sound operation of the plants, at least the plants the projects we are involved in. So we are one of the energy companies, utility in Germany. We generate electricity, we trade with electricity, we are operating grids, having customers, selling to them, roughly like 6 million customers we are supplying so far, or now it's less, so 5.5 million customers, we have 20,000 employees. We have a generation capacity of 13 gigawatt installed in Germany. This is mainly nuclear power and coal-fired power plants. And by the German legislation, we will quit with the nuclear power and we are going to switch off a few gigawatt capacity within the next years. So we have somehow to deal with it and to replace, well, in our case of our company, 2 gigawatt installed capacity. And as we are located in the southwest of Germany, where we have no harbors, well, gas is quite, natural gas is quite expensive. We have somehow to get some other resources there, because we can't compete with a coal-fired power plant which is directly located at a harbor. We don't have mining there. So far we got 50% or actually a little bit more of our power generation from nuclear power, but we have to switch this off. So we are looking in new technologies, and one of this is geothermal power. Also the temperatures and the conditions are challenging in Germany. So here you see a map of Germany with the 3 areas where you can find hydrothermal reservoirs. This one, and the temperature scale goes up to 200 degrees. So here actually we have 150 to 200 degrees, and in the rest of the Germany you don't find that high temperatures, and this is in a depth of 2.5 kilometers. So I think the highest temperatures you can expect in Germany are 200 degrees Celsius if you go down maybe to 4.5 or 5 kilometers depths. So the German market in general is actually, well, just some words to the conditions. So the drilling depths are usually between 2.5 to 5 kilometers deep. Most of the projects have 2 boreholes, some have 3, so 1 production and 1 injection or 2 injection wells. Flow rates are between 50 and 150 liters per second. And the projects listed here, these projects are all smaller than 5 megawatt electric. And the recent projects now, which are developed in the area of Munich, they have temperatures around 130, 140 degrees, flow rates of 120, 140 liters per second, and they get up to 5 megawatt electric, but they usually are combined cycles, so CHP plants, focusing on heat supply in winter and producing power in summer. As you see, there are some projects and going on in Germany, but it's not that much, and these are all small projects. But there is something going on. So we are involved in 2 projects. both are R&D projects. As I said, we are, or I work in the R&D department at my company. So in our view, geothermal energy in Germany is still, at least power production from geothermal energy, is still in the R&D or demonstration phase. That's why it's running in the R&D department, and we are operating 2 small plants, or we are involved in this project. So one is the Bruchsal plant, which is close to our headquarter, which is located in Karlsruhe, southwest of Germany. It's we just produced 25 liters per second from existing wells. The wells were drilled down in the 1980s, and we started to step in the project in 2005, and then we built up the power plant. It's a Kalina cycle built by Siemens. There are 2 of Kalina cycles existing in Germany. One is in Unterhachingen with 3.6 megawatt, and this one with half a megawatt capacity. So this is a R&D site where we focus more on the power production. It's a hydrothermal reservoir with a doublet. 2.5 kilometers is the production well, 1.8 kilometers is the injection well. What we like to figure out here is if the Kalina cycle is really better than the ORC cycle, or if we go to really low temperatures with 120, 125 degrees, as we have in Bruchsal, if we really favor from the, well, at least theoretically, thermodynamic favorable conditions during evaporation. The other project we are involved in is the EGS project in Sulz-sur-Forêt. We have a triplet there, so 3 boreholes down to 5 kilometers directly in the basement, and we are working there in the granite, operating the system by 2 production pumps. Well, right now these are just 1 pump, but we had an ESP pump, an LSP pump. We have actually all the projects in Germany and in this area have problems with the pumps. So if there are any pump manufacturers around who know solutions, we are open for them, for the solutions, because in all the projects, in all the power projects in Germany, the average lifetime of the pumps are less than 1 year. So we have to change pumps very often. In Sulz-sur-Forêt, the special problem are the granite particles, but also water chemistry and temperature. As we have here, it's temperatures up to 175, maybe also 180 degrees. The reservoir temperature in Sulz-sur-Forêt is 200 degrees. So it's also a small project, 2.1 megawatt gross electric power, an ORC with a radial turbine. So nothing really special from the power plant point of view. But it's a really exciting project if you want to learn how to operate an EGS system and how to enhance an EGS system by stimulation, but also by just operating it, because the reservoir changes quite a lot during operation. But now we're getting to the topic of what the presentation is about, the environmental impacts and the environmental sound operation of these plants. So I just listed up some of the issues we are dealing with. This is, of course, land use. It's not that huge if you have just 3 boreholes and they're located at the same place, but it's still an issue. It's a visual impact, it's a seismicity, especially in the EGS project, the release of the different working meteors and the different phases of the brine, and natural radioactivity. So noise management is also one crucial item you have to focus on during operation, because if you have a look how the projects in Germany in future will be operated, they are heat and this will be heat and power projects. So they will be most likely nearly located to households, to cities. So noise management is something you have to deal with. And of course, the main noise sources are the turbine, the frequency converters of the pumps, and the cooling tower. So just some examples how we dealt with this. For example, in the project in Sulzu-Forêt, we just made a turbine housing because the whole installation is outside installation. This is quite easy, but it costs money. For example, what we did in our Bruchsal project with one of the frequency converters, we just put the frequency, so there is on one side there are households, on the other side there is an industrial area. So we just put the frequency converter behind the existing building on our site, so actually behind the machinery hall, so that we shade the living houses, and the noise is reflected to the industrial area where nobody really cares about it because it's also very close located to the highway. So this is something which you can do without actually spending money. You just need to think about it. Something else is noise prevention from cooling towers. We have also one wet cooling tower, and the noise level can be quite high. So we put something, and the noise actually is produced by the water which drops on the water surface, the water droplets. So you can put something on the surface of the water. They're like plastic layers, and then the water will not hit, the water droplets will not hit the water, but they will just hit this plastic layer swimming on the water surface, and you can actually reduce the noise level in a relevant size. So that's how you can easily do it with also low-cost solution. Monitoring of natural radioactivity is a quite large topic, or maybe will be a larger topic even in future in Germany, as the branch is quite new and nobody really knows what geothermal energy is. The concerns of the public are quite high, and of course we have to deal it with it. And what we try is actually to use existing knowledge. So in France, it's the same as in Germany. They are quite experienced with operating nuclear power plants. So we try to get in contact with the operators in France, with the operators of the nuclear power plants, and the same we're doing in Germany, and also with the authorities who usually control the nuclear power plants. They are also in charge of controlling the geothermal power plants, and they actually they don't know really how it works. So it's a kind of going this way together, going through together. So in the project in Sulzu-Forêt, which is, as you saw, just 2.1 megawatt gross electric power, it's 1.5 net electric power, quite small production capacity. We have a radio protection officer. We have a radio protection zone. So we have a blue line on the ground, and everybody who steps into this area needs to wear a dosimeter, needs to be controlled quite regularly, and that's also a kind of protecting the staff on site. So it's also quite new for us to educate people working on a geothermal power plant how to deal with radioactivity. The radioactivity comes from the granite and accumulates in the scalings. Of course, not in all scalings. Like calcite, we don't find a lot of radioactivity in calcite scaling, but if we have, for example, barite scalings, then the radionuclides will accumulate in there, and you have to measure it. And if there are some maintenance work, you have to go through the procedure with the staff on site to minimize risk that they breathe, for example, some particles if they cut pipes or something like this. This is done together with the French authorities. We have over 350 measurement points. You see each thing here, each dot here is one measurement point, and we measure this regularly. So as I said, this is an R&D project, so we are going to develop procedures how we are going to proceed with this topic in future in commercial plants. So we monitor it, and actually it changes. This is what you see here. So each dot, these are the measurement points. So measurement point 0 to measurement point 350. I think it's not like 350. It's one or a few less or more. And you see then with time the concentration increases until you go to clean it or you replace the pipes and the scales are away. Then it drops again down, and then it starts to the activity starts to rise again. This is the hot part. Of course, we find less scaling there and less activity there. And this is the cold part. So we find the barite scalings there. Actually, there's something which is quite interesting. As we can measure the activity, we can also measure the scalings in our pipes. So we can easily monitor how much scaling we have in the pipes in the cold side. This is some positive effect of this radioactivity. The negative is we have to pay for disposal because it has to be disposed like other radioactivity waste. And that's why we're working on ways to reduce this. One might be to apply coatings to the pipe, like inner coatings of the pipes, and to avoid that the scalings will be in the piping itself, but we just inject it back into the radionuclides back into the reservoir, and reducing cost for disposal in this way. The same we do in Bruchsal. There we have a hydrothermal reservoir in shallower depths, so we never measured really radioactivity there, but we still do it just to be transparent and to be proactive and communicate with the public there, just to make sure that we won't get it also there, because we don't know really, we might get problems in future. And there we work also close together with our staff from the nuclear power plants. So then the next topic, seismic activity. It's a huge discussion in Germany. So there was seismic events triggered by a geothermal project close to our projects in Landau a few years ago. And so it's a discussion in the newspapers and in public. And if you want to start up new projects, you will have to deal with it, because there will be some people who create initiatives to stop the projects, because they are frightened that you will get seismic activity there. And if I talk about seismic activity, then it's always like two different kinds of. There's one which is actually kind of wanted seismicity. This is a microseismicity we are using for monitoring of our reservoir, for example, in the EGS project, that we see how it develops. And then there is unwanted, the sensible seismicity, which is felt by the people, and we try to avoid this. But actually there are also two ways how to monitor it. So if you want to monitor the microseismicity, well then we do it with geophones in observation boreholes. But if you just want to make sure that there is no sensible seismicity, you can go on a cheaper network and just measure the surface velocity. And there is one norm in Germany, the DIN 4150, which actually describes how to do it. And this will also withstand for if you have to go to court, if there is somebody claims that you damaged with your project his house or something like this. The data assessment in our project is done by a university, just to make sure that it's done by a kind of neutral person, and the data are available also to public if needed. So this is a microseismicity monitoring at Bruchsal. And here you can, so we have the two boreholes here. This is a doublet, this is the production well, injection well. There is 1.5 kilometers in between, and we have the 4 observation holes around it. And that's what we measured so far, and we couldn't measure so far seismic activity there from the operation of the plant. But what we could measure is the highway here, and this you can see very nicely here. So you can see the whole week, and you actually see also the weekend, because at the weekend in Germany on the highway, trucks are not allowed to go. So it's a really nice picture. Hopefully it will stay like this and we will never observe something else. In Sulz-sur-Forêt, with the EGS reservoir, it's different. Here we used the microseismicity network, the detection network, to have a look how the reservoir developed. And each of these clouds, dot clouds in another color, is one stimulation phase. But I have to hurry up a little bit. So maybe just one more about the gas handling. For example, in our Bruchsal project, we have quite a lot of gas. So the gas to liquid ratio is 2 to 1. 2 liters of gas to 1 liter of water if you go on the norm cubic meters. And of course, if you have a binary cycle and you don't want to have a lot of gas in your heat exchangers, because they will block the heat exchange. So you have to deal somehow with the gases, and we are not going to release it to the atmosphere. We just, as we heard before, we actually inject the gas back into in the injection pipe. So it's a small plant, so it's very easy there. What we do is, before the brine goes to the plant to cool down, we just separate the gas, which is mainly CO2, so it's more than 90% CO2, some nitrogen and some methane, and we have a pressure drop in the power plant due to the heat exchangers. So we use actually the natural pressure drop over the heat exchangers to drive the gas out of the before the plant, out of the brine, and inject it back afterwards. After the heat is extracted from the brine, the CO2 easily dissolves again in the water, and we have 1.5 kilometer pipeline for this. And we can also observe, then we have an observation window, and the gas is dissolved again, and we can inject it back into the ground. Well, that's how we do it with the operation of our plants, and I want to thank the Ministry of Environmental, Nature Conservation and Nuclear Safety in Germany, because they're funding our work, and this will hopefully help us to safely and secure, environmentally friendly operate our plants in future, if we are able to establish economically projects in Germany in future. So many thanks to the audience.